Hey everyone, welcome back to another lesson. This is lesson 6 in Unit 3 of our Algebra 2 course. Earlier, we talked about systems of equations. That's what we've been working on in the last 5 lessons. Today, I want to talk about systems of inequalities. So, in order to represent these solutions, they're not going to be necessarily a single point. In general, they're going to be a region, an area. And that area could be confined, or it could be, it could go off forever. Lots of different ways these things can happen. Now, solutions to systems of inequalities is kind of one of those topics that we're just going to hit and then kind of move on. Unfortunately, we don't have the time. It's not really in the scope of this class for us to go really deep into it, but it is really important. It's used all the times in different like economics models and problems. It's used a lot in computer science and computer programming for solving problems. So linear systems of equations, really important stuff. It's a skill I want you to have. So let's get right into it. All right. We're going to graphically represent the solution to the following systems of inequalities. I have x minus y is less than or equal to 6. All right, well, let's go ahead and graph that. So the boundary line we can quick graph. We can find the x and y intercepts. The x-intercept would be 2 because you put a 0 in for y. 3x equals 6. X equals 2. The y-intercept, if I put a 0 in for x, is a negative 6. Since it says less than or equal to 6, I'm going to use a solid line. You also should have the ability to tell the slope of this line by solving for y in your head. Move the 3x over, it becomes a negative 3. Divide by a negative 1, and the slope is a positive 3. Because when you solve for y, it's the number in front of x. So we know it has this slope of 3. That's another way it can help us graph it. Let's draw the line through these points. All right, and we need to figure out how to shade. So I'm going to test the point 0, 0. If I test the point 0, 0, I would get 0 minus 0 is less than 6. Well, that tells me that it's true. So that means that I need to shade all of this stuff over here. So let's do that. Let's shade over there. Now I'm going to just grab like a. See if I can't just use this little spray painter thing here. See if that doesn't make it easier for me. So yeah, there we go. That's perfect. I just want to shade all of this here. Okay? Real lightly, because we're going to come back in and darken the answer. And you may even want to just, wait till the end and do tiny little markings so that you can make your answer clear. All right, I've got x plus y is greater than 2. This one's going to be a dotted boundary line because it says greater, not greater than or equal to. Again, I got an x-intercept at 2 because I put a 0 in for x. I get, y, I get x equals 2. Put a 0 in for x, you get y equals 2. If we were to solve this boundary line for y, we would get a slope in front of the x of negative 1. So, and that seemed to line up. So let's do our dotted line here. All right, now let's test the point 0, 0 again. If I plug in 0 for x and y, though, 0, 0 is not bigger than 2. So, in fact, I really should only be in this region over here. So, let's darken that. Darken all of that. And these other regions here, we could come back in here and erase it, but I'll be erasing my graph if I do that. So I'll just leave it to your imagination. But I think it's pretty clear that I mean this area up here. All right, next we have y is less than or equal to 4. I'm going to use a different color this time. Less than or equal to 4. So 0, 1, 2, 3, 4. That's going to be a horizontal line. And then less than is down below. And so that, and this is going to help me darken it in here. This is now where I'm looking, right? And then finally I have x greater than 0. Well, x equals 0 is this line here. So like a dotted line. And so it's going to be greater than, so it'll be all of this. And, if I was using pencil or something like that, I might come back and and erase all this. But like I said, it's kind of hard to do that when you are doing it on a computer screen. But that gives you kind of the general idea of what's going on, right? So it's this region here. That's our solution set. Our solution region, I should say. All right, let's try another one. I've got y is less than x. Okay, so that's easy to do with slope-intercept form. It just goes through a y-intercept of 0 and a slope of up 1 over 1. And it's y less than, so it'll be a dotted line, and we're going to be shading down below. So I'm going to be shading down this way, right? All right, so then x is less than or equal to 5. Well, then x equals 5 is this vertical line here, and less than is going to be to the left. So since I'm down below this blue line and I'm to the left of this red line, it's going to be this corner over here. All right, and lastly, let's find the x and y intercepts here. I have an x-intercept of 8 and a y-intercept of 8/3. Well, that's not very pretty. I could solve it for y, solve the boundary line here, and I get negative x plus 8 is equal to 3y. So then y is greater than or equal to a negative 1/3 x plus 8/3. Well, that's not really very pretty either. I'll tell you what, though. Let's plug in a number for x and see. Let's try plugging in some numbers for x and see what we get for y. So if I plug in a 2 for x, 2 plus 3y equals 8. Well, that's going to tell me that y has to equal 2. Because if x is 2, 2 plus 3 times 2 is 6 is 8. So when x is 2, y is 2. And we know we have a slope of down 1 over 3. So down 1 over 3. And it's a solid line. And since I solved it for y, it tells us that we're going to be shading upwards. So my whole region is this tiny little triangle. And I know I didn't shade everything, but hopefully you'll be able to follow how I did that. It's going to be a little easier for me not to erase everything. But normally I would lightly shade each thing and then go back and darken it in if I was doing it on paper. All right, so again, let me just go over how I handled this idea. The y-intercept was 8/3, so it's a fraction. My line is actually not graphed perfectly here. It's not bad, but it's a little bit off. It actually should be more like these. Because we know it was close to right. There we go. Something more like that. And I just started plugging in numbers, and I knew 1 didn't work because then I'd have 3y equals 7. So I moved up to x equals 2. Gave me a point. And once you give me a nice lattice point on the grid lines, I can use my slope to find another. All right, I want you to practice now. So graph the solution of this system of inequalities. All right, let's see how we did. I've got x minus y is less than 4, so I've got 4 on the x-axis for the x-intercept. I've got negative 4. If you solve this for y, you'll get that the slope is 1, and we'll be having a dotted line. I'm going to test the point 0, 0. 0, 0 is less than 4, so we're going to be shading up above here. Everything's going to be up above. Y less than or equal to 1. Well, less than or equal to negative 1, excuse me. So this is y is less than or equal to negative 1. It's going to be that horizontal line and shading down below. Y equals 1 is a horizontal line. Then x equals 1 is a vertical line through 1 on the x-axis. So it'll be going to the right. So it turns out that it's this region here that was in all 3 areas. All right, let's try this next one. Go ahead and pause the video if you haven't already, though. All right, we're going to be doing point slope form on this first one. The x-coordinate is negative 6 and the y-coordinate is positive 4. And we have a slope of negative 1/2, so down 1 over 2. And it is a solid line. Oh, I can do better than that. Let me get the line tool. Perfect. All right, and we can test the point 0, 0. If I move the 4 over, I get y is greater than or equal to negative 1/2 times x plus 6 plus 4. That's a lot easier for me to look at. I can see y is greater than this line, so it's got to be up here. So as long as I've got y isolated, I can use the greater than or less than though if I shade up or down. All right, let's do the next one. I've got x plus 6y less than 18. So x-intercept of 18 is probably not that helpful. I'm going to solve this for y. So I have x plus 6y less than 18. So 6y is less than a negative x plus 18. And I'll divide by 6. When I divide by 6, I get a negative 1 over 6x plus 3. So I'm at 3, and I'm going to go down 1 over 6. Well, that's right there. And also go up 1 over 6, and that's right here. I lost my inequality, though, somehow. All right, I have less than, y less than, so I'll be shading below. Okay, be shading below this line. So we're looking like down here, right? And then the next one is x minus 2y less than or equal to 2. So if we use the x-intercept is 2, the y-intercept is a negative 1. That's pretty helpful, actually. I can draw a line right through that puppy. And it is a solid line. Oh, the last one should have been a dotted line. Wow, why didn't you say something? Well, I can go back and make it dotted. Hold on. Dot, 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 dot. There we go. The other two are definitely solid, though. All right, well, this one here, I'm betting is shading up, but let's find out. Maybe not. We don't know. Maybe this area over here to the right. It says, let's see here. Let's plug in 0, 0. If 0, 0 is a solution, then I'd be shading over here. 0 minus 0 less than 2. 0 is less than 2. So this is our solution region. Okay. Example 6.2. Write a system of linear inequalities that represents the following solution region. Okay, well, we can do that. So let's start with this vertical line here. This, if I was going to extend this dotted line out, you can see it's a vertical line at x equals negative 3, but we're shading to the right. So I'm going to say that the first inequality is x is greater than negative 3. All right, now this next one here, we're definitely shading below. This is a solid line that we're shading below. All I need is a point and a slope. I got a point right here at 3 comma negative 2, and I can use that for both lines too. So I'm going to say y plus 2 going below, so less than or equal to negative, what is that, a 1/6? Down 1 over 1, 2, 3, 4, 5. It is. Times x minus 3. Point slope form makes it so easy, y'all. All right, this next one we're shading above, so it's going to be a greater than or equal to. Let's use our same point slope setup, y plus 2. And then it's going to be something x minus 3. Remember, it's the opposite of the number with y and the opposite of the number of x from the point. This is a slope of up 1 over 2. Up 1 over 2, up 1 over 2, up 1 over 2. So that's just a positive 1/2. So that's pretty easy. I like doing that. That's nothing, I don't have to color or anything like that. So hopefully you won't find it too bad either. And give it a shot. Write a system of linear inequalities to represent this solution region, please. All right, let's see how you did. I'm going to take this flat part here. I'm going to say y is less than 5. That's going to give me below this line and dotted. I'm going to take this next line over here. It's a vertical line, so it's x and 5, but this is shading to the left, so x less than 5. Hopefully you realize that this was supposed to be on that line there, but it's not that easy to do. It's a solid line as y is greater than or equal to 2, because I'm shading above. And we only have one real linear equation that's of any kind of consequence to deal with. I'm going to use this point here. That is 3 comma 5. So y minus 5, and I'm shading below it, so less than or equal to. The slope is up 1, 2, 3 over 2. 3 over 2 times x minus 3. And that's all there is to it. All right, you got another one? Try this one if you haven't already. Okay, for this one, the vertical line is x is greater than or equal to negative 2. X equals negative 2 is this line, and we're shading to the right, so greater than or equal to. And this next one, we have I can use y equals mx plus b just to make it fun. Y is less than or equal to, the slope is, what is the slope? Down 1, 2, 3 over 2. So negative 3 over 2 times x plus 1. This next one here, I can use y equals mx plus b as well, and y is greater than or equal to, because from this line I'm shading up, and that's a slope of negative 1, so negative x and a y-intercept of minus 1. Okay, that's it for today. So take care, and I'll see you in the next lesson.